Assalamualaikum. My name is Siti Nalila Kurnia binti Muhammad Jeffrey.
Hello and Assalamualaikum. My name is Umarul Sidki bin Ismail.
Assalamualaikum. My name is Siti Suhaida binti Sulaiman.
Assalamualaikum. My name is Tuan Nur Amalin Kisina binti Tuan Azliman.
Okay, let's start. What is differentiation? Differentiation is the action or process of differentiating between two or more things or people. It's the same for differentiation in calculus, but differentiation in calculus is a process of finding a function that outputs the rate of change of one variable with respect to another variable. This is also equivalent to find the slope of the tangent line to the function at a point.
Differentiation is also important when you want to start a business. In business, you must have a good marketing,
Differentiation in marketing means creating specialized products that gain competitive advantage with particular segment of market. Differentiation makes a product or service more desirable to the target market. The more you produce, the more cost you need it.
For example, a company produces X units of products for the total cost C of X is given by the function is Cx 3x squared plus 36x plus 15. X is number of units and Cx is the cost price. Then we have to find out what is the marginal cost when company produce 10 units of production. So marginal cost means increment or decrement in the cost when company products increases by 1 unit. So we start with differentiate the equation given by bringing the power to the front and power minus 1, and for the differential of constant function is 0. Assume that variable of x is 10 units that we have to find the cost. Then we got 96 as the cost of 10 units.
First and foremost, let's go to the first subtopic, which is related rates. As for the question, a conical water tank with vertex down has a radius of 10 meter at the top and 24 meter high. If water flows out the tank at a rate of 20 meter cube over minute, how fast is the depth of the water decreasing when the water is 16 meter deep? In this case, we use the ratio method for the cone problem. As you can see in the picture, the radius is 10 meter. The height of the cone is 24 meter, while the height of the water is 16 meters. So in this question, we are looking for the dH over dt when h is 16 meter. And the other information that we will get is dV over dt negative 20 meter cube over minute. The negative dV over dt is inferred from inclusion of the words flows out in the problem. So dH over dt equal to dH over unknown times unknown over dt. It will become dH over dV times dV over dt, since the only information that we got from the question is volume. The important thing that we need to know in this case is the formula of the volume cone, which is 1 over 3 pi r squared h. So as for the first step, we need to express V in terms of H because dH over dV is needed, as you can see in the previous slide, dH over dV. So we use the ratio method, which is R over H became 10 per 24. So we make the R as the variables and became 5 over 12H. And then we put the 5 over 12H in the R for the formula of cone. Next, we are going to divide the dV over dH, which is 25 over 432, and it will become 25 over 144 pi h squared. So in this question, we already have the dV over dH, but in the previous slide, all we need is dH over dV. Therefore, we need to inverse it and it will become 1 over 25 over 144 times 2 negative 20 meter cube, which is dV over dt, and we will get 20 over 25 over 144 pi h squared. So we replace the h into 16 and we will get negative 9 over 20 pi or negative 0.1432 meter per minute.
Consider the function fx equal to x squared in bracket x plus 3. So, solution. Settle with the equation first. So, we start with x intercept fx equal to 0 and x equal to 0 or x equal to negative 3. And y-intercept x equal to 0. So, we just substitute the value of x in the equation. So, y-intercept is 0. So, we move on to B question. Step 1. Find the derivative of f prime x. F prime x is equal to 3x squared plus 6x. Step 2. Let f prime x equal to 0. So, step 3. Critical line. Draw the critical line just like in the diagram. Step 4. First derivative table. So, this is the kind of table that needed to be constructed. Step 5. Choose the correct sign. Step 6. Determine the extremum points. When x equal to negative 2, we substituted the value of x into the equation. So maximum point is negative 2, 4. When x is 0, we substitute the 0 value into the equation. So minimum point is 0, 0. That's the solution to the B question. So we move on to the next question, which is C question, where we need to determine the inflection points if there is any. So the first step is we need to find the second derivative, f prime prime x. So how to find second derivative? We take the equation from the previous question where f prime x. So in order to produce second derivative, we just differentiate the whole equation all over again. So it will be f prime prime x equal to 6x plus 6. So then that's how we find the second derivative. So we move on to the next step. We let f prime prime x equal to 0. X is equal to negative 1. So the next step is we need to draw the inflection line. So this is the inflection line as shown in the diagram. The fourth step is we need to construct the second derivative table. So as you can see, this is the second derivative table. Step 5 is we need to choose the correct sign. Okay, so the last step is step 6, where we want to find and determine the inflection point. So when x is equal to negative 1, we substitute that x value in the equation. So the inflection point is negative 1, 2. So this is the graph showing the inflection point.
For an example, is analysis of function 2 is the same with analysis of function 1, but it has asymptotes, which is a straight line that a graph approaches without touching. Given a function fx equal to negative x per 1 minus x plus 4, let's start find the x and y-intercept if any. In order to find the x-intercept, we have to assume that y equal to 0 or fx equal to 0. Settle it by leaving the x alone. In order to find the y-intercept, it's the same concept, which is x equal to 0. Substitute x equal to 0 into the function and you will get the y-intercept value. So our x-intercept is 4 over 5 and y-intercept is 4. For B, we have to find the vertical and horizontal asymptotes if any. In order to find the vertical asymptote, we have to simplify the function. In order to find the vertical asymptote, we have to take the value in denominator from the function and let it equal to 0. And settle it by leaving the x alone. With the value of x that we have got, use the limits function method to find the analysis of vertical asymptote. In order to find the horizontal asymptote, we use the infinite limits method. C, we have to determine the intervals where the function increasing or decreasing. For this question, first we have to find the derivative, which is we have to use the quotient rule. After we got the first derivative function, we have to let the function equal to 0. Then we have to construct the critical line and the first derivative table. By substitute the test value of first derivative function, we can determine the increasing interval or decreasing interval. If we get the positive value, it will be the increasing interval. If we get negative value, it will be decreasing interval. Next one, D. We have to determine the intervals where the function concave up or concave down. First step, we have to find the second derivative function. We will use quotient rule method on the first derivative function, and then let the second derivative function equal to 0. Construct the inflection line and the second derivative table. By substitute the test value into the second derivative function, we will determine the concave up and concave down. If we get the positive value, it will be the concave up, and if negative value, it will be the concave down. For the last but not least, find the inflection point and using all the information from A to E to sketch the graph. For this one, we just have to substitute the value of x that we have got earlier into the function given in the question. If undefined, that means inflection point does not exist. Construct the graph by using the information we have got earlier, which is the vertical asymptote that we get is 1 and the horizontal asymptote that we get is y equal to 5. And x-intercept is 4 over 5 and the y-intercept is 4.
For 3.4 applied minimum and maximum problems, question is from example 9. The question given, a closed cylindrical container of radius rcm and height hcm is to be made to hold 600 cm cube of liquid. For question A, show that the surface area of the container is 2 pi r square plus 1200 over r. The solution of question A, we should know how to show the surface of the container is 2 pi r square plus 1200 over r. First, write the area formula for cylinder equal to 2 pi r square plus 2 pi r h. From the question, given volume of cylinder equal to 600. So, rewrite the formula on how to find the volume of cylinder is pi r square h equal to 600. Then we get h equal to 600 over pi r square. Next step, we use substitution to replace h with 600 over pi r square. So, we get the area of cylinder equal to pi r square plus 2 pi r h be 2 pi r2 plus 2 pi r times to 600 over pi r2. Then, for the last answer, we get the area of cylinder equal to 2 pi r square plus 1200 over r. Next, for question B, find the values of r and h that minimize the total surface area of the container. So, for the solution for this question, have a few steps that we should know. For the first step, find the first derivative for area equal to pi r square plus 1200 over r. Then we get dA over dr equal to 4 pi r minus 1200 over r square. In step 2 is let the first derivative equal to 0. So let dA over dr equal to 0. And at last we find the value of r equal to 4.57 cm. Step 3 is we find the second derivative test from the first derivative. So d square a over dr square equal to 4 pi plus 2400 over r cube. Then enter the value of r equal 4.57 and get the value is 37.71 more 0. So r is a minimum value. Last, we use the value of r to find the height and we get the value of height is 9.14 cm. Next, for the question C, hence find the minimum surface area of the container. So for this type of question, we find the minimum area use the equation 2 pi r square minus 1200 over r and just replace the r with the value is 4.57. So for the last answer, we get the minimum area is 393.81 cm square.
Last but not least, let's go to the subtopic Rolle's and the mean value theorems. As for the question, the Rolle's theorem states that if fx is differentiable on AB, continuous on AB, and fa is equal to fb, then there is at least one point which is C in AB where fc is equal to 0. If fx is equal to x to the power of 2 minus 3x, find the value of c in the interval 0-3 that satisfy the Rolle's theorem. As for the solutions, first step, we have to put the value of 0-3 in the equation of fx, which is x to the power of 2 minus 3x. So for the value of fa, we get 0. Same goes to the value of fb, which is also 0. This means the requirement of fa is equal to fb, and this means it is continuous. For the next step, we have to differentiate the fx equation and became 2x minus 3. And then we replace f prime x to c and become 2c minus 3. And then we have to let fc equal to 0. So c equal to 3 over 2. And this means the 0-3 is an element to fx equation because we got the value for the c, which is 3 over 2.
After all, differentiation is so important. Differentiation can help us solve many types of real-world problems with to determine the maximum and minimum values of particular functions.
I guess that is all for our group. Thank you.